Okay, so I'll just share my screen now so we can start the lecture. Can you see my screen? Can you see my screen?
Yes, ma'am.
Okay, so let me put it in slideshow. So you're welcome to ICH 512. My own section is mechanical pulping. So today we're looking at groundwood and refiner wood pulping. The other lecturer is taking you on chemical pulping, the other aspect. So what we have to consider first when we're looking at the pulping, mechanical pulping, or any industrial process, you have to see to it that you have the proper raw material. And so that's why we're starting with the raw materials for this. So we have different types of raw materials that can be used for pulping. The fibrous material, which can come in form of wood. It can come in form of other plant materials like straw and reeds, so on. The other material is just wood itself. You have the different types of woods that are used for pulping. You have the softwood and the hardwoods. Then the wood, you have to prepare it. You don't just carry a whole wood and put, so you have to prepare it and cut into logs. Logs are bigger pieces of wood. So they are chipped directly, or you can also have chips. You have logs, the bigger pieces of wood. Of course, they must have some size that are acceptable for the process. And then you have chips, which are much smaller. You can get them as residuals from sawmill operations. And so you can even chip the wood by yourself the way you want it, to small sizes for it to go into the mill, the pulping mill. And so how do you handle the raw material? So first of all, we look at the measurement, physical measurement of the raw material. So it's important to determine how much wood is coming into the mill. I'm talking of the pulping mill, mechanical pulp mill. So you determine how much wood generally is coming into the mill. That's one first thing you have to do. You also have to determine how much wood is being charged into the digesters, how much is going in for the pulping. You also have to also know how much actual wood mass is being charged in. So you will be able to know the correct ratio of the wood to liquor. That is the solvent you're using and the wood you're using. You have to know the ratio. It's a particular ratio that can be used. As we go on, you'll be able to understand all this. So I'm talking of how much actual dry wood, how much actual wood mass. If you just put in the wet wood and weigh it and think, oh, that is what is going in, it's not the proper one, because the wet wood is still carrying a lot of moisture in it. So, and the ratio of the wood you charge in to the solvent that you're adding in it will not work. So you have to know the exact wood mass. So you have to know the dry mass of the wood. So you put the proper ratio of the liquor, and so you'll be able to know the proper ratio of liquor and the wood that is in there for the pulping. So in mills, you have to use scales and other devices. And what those scales, all the devices that you use are moisture content meters. So you'll be able to measure the moisture content. Then the laboratory chip screening, you have to screen the chips, that is sieving it to get the exact size that is suitable for your pulping method. Then wood species determination, like I mentioned, softwood, hardwood, so you have to also determine the wood species that you're using, so you'll be able to do the proper thing. Okay, so moisture content, we have two different types that you carry out. Moisture content green, and the other one, oven dry. The green moisture content is the moisture content that you carry out on the wet wood, the wood you just cut and bring in for this without drying it. That wet wood, you carry out the moisture content directly. And so that's what we have here as MCGR, moisture content green, that is of freshly cut wood. Mostly you have the moisture content of the freshly cut wood between 30 to 60%. So in an average, generally, you just look at it as 50%. Then this is how you do it. The moisture content of your freshly cut wood is the mass of the water in the wood divided by the wet wood mass. You multiply it by 100 to have it in percentage. For the oven dry wood, you have already dried the wood. So that particular oven dried wood, you now check the moisture content. Of course, you know that oven dry wood will still have some moisture in it, but it's not, because it's not completely dry. And then, of course, it's different from the one that you cut directly and check the moisture content. So for the oven dried wood, you just use the same method. The mass of water in the wood, that oven dried wood, over the oven dried wood mass times 100 gives you the value in percentage. Another thing you have to carry out is solid wood density. The mass over volume, weight over volume. So you know the weight of the dry wood and then the volume of the wood, and divide by the weight of the dry wood by the volume of the green wood. Dry weight of the wood by the volume of the green wood. So that gives you it gives you the value in either pounds per cubic feet or kilograms per cubic meter. Of course, you know we're using kilograms per cubic meter. So wood on its own, it contracts about 8 to 15% volume. Sorry. On volume basis, when it dries below 30% moisture. So you have to consider that also when you're calculating your density. So another thing we do also in handling the raw material is debarking and chipping. Debarking and chipping. Sorry, let me admit your colleagues in here. Put that in. So debarking is what we do, and chipping. So from the name there, debarking, you peel out the back of the wood. So there are many mechanical systems that can be used to debark the wood and also to chip the wood. You would chip the wood, you cut it into chips of the size that's suitable for the pulping. So important points that you should note in this case is that you should get all of the back of the log, remove it all. And then the bark typically is used as fuel source, because the dry bark of the wood can be used as fuel source for burning. Then the chip, it should be consistent size. You chip it, you cut the wood, you're chipping it, you want to use chips, you cut into consistent size. So, and it has to be a uniform size of wood. So it's very important for the chip size to be uniform. Why is it so? Very large chips undercook, leaving chives. Chives are the rejects. Let me just use an example for you. Maybe you have seen some exercise books. They're not really white in color. They're somehow brownish, and they have some little things like pieces of wood, just slight. So those are chives that are in it. You're using wood for pulping, and then tiny pieces of wood that are not completely pulped, removed. So those are the ones that, if the pulp is used for paper making, you will see some tiny things like that in the paper. So, and also during the pulping, these chives need to be removed. And when I show you the whole pulping process, you will see a stage where you have to do screening, sieving it, and removing. So you will have a lot of chives if you did not cut your chips properly. It will undercook and to produce too much chives. What I mean by undercook is that before you use your chips, you will have to cook it a little bit with some chemicals. So, which I will show you later on as we go on. Just a little chemical to soften it. So if the wood is bigger, then the chemical will not be able to get in well to soften it properly. And so when you put it in the grinding, or yes, when you're grinding it, it will not grind it properly. So small chips clog liquor circulation. So if it is too small also, it's a problem. It will not allow the liquid in that mixture to move freely. So it clogs it. So to use, you now have to need to use large amount of chemicals to be able to free the chips so it doesn't clog the liquor. So if this happens, if you use small chips, it will give low yield and very weak pulp. Of course, weak pulp is not going to produce strong paper. It will produce paper that is not strong, it's weak, and it can easily tear. So chip thickness is of primary concern. So now, what are the properties of mechanical pulp? Mechanical pulps have different properties from chemical pulp. So in my own section of the lecture, we're looking at mechanical pulp. And I know also the other lecturer will teach you chemical pulp. And I know from that, you'll be able to know the difference between that one and mechanical pulp. So for mechanical pulp, they are really cheap, relatively cheap. Relatively cheap. They have high yield of products. That's why they're relatively cheap. They have low capital costs relative to kraft mill. Kraft is that of chemical pulping. So because the yield is high and the capital cost is low, then this one is cheap. And I'll tell you why the yield is high and as we go on. So another property is high opacity. So this opacity is the quality of lacking transparency or translucence. So it's not transparent. Then it has large amount of fines in products, and it scatters light. It allows printing on both sides for thin sheets. So even though the sheet will be thin, you can print it on both sides and it comes out very good. It has good printing surface. So broad fiber size distribution gives smooth surface and it has good bulk. As we go on, you will know why all these properties are attributed to mechanical pulp. Because you don't lose much. It's like almost everything that you put in the wood comes out. Nothing is washing anything off. So it's just like you have almost everything that you put in. That's why you have the yield is from 85 to 95% of what you put in. So it's relatively weak product. Produces relatively weak product, not strong enough to get through printing press. It needs to add chemical fibers to the product so that it can give it a little more strength. So, and I think in this lecture, you will see the different papers that are made from mechanical pulp, and then you'll be able to understand what we mean by the product is weak. It also has limited brightness. So, because the mechanical pulp bleaching is different from that of chemical bleaching. So, the mechanical pulp bleaching leads to the retaining of the bleaching agent, and so the brightness is not that good. And then there's also photo yellowing in mechanical pulp, papers produced from mechanical pulp. And the reason is because of the formation of chromophores from lignin. Wood itself is the cellulose bound by lignin together. So that thing that binds the cellulose in the wood together is the lignin. And so in lignin, you have chromophores. The chromophores are the color forming material. And so since the pulping of mechanical pulping does not remove lignin, so the color forming material is still retained in the pulp, and you use it to make paper. By the time you keep the paper for some time, then with light and oxygen reacting, then the chromophore is formed back. So the color forming material is formed back. That's why you see the papers that is produced through mechanical pulping. After some time, initially the color will be brighter, but with time, the color keeps changing. So you have your exercise book or any book you keep and you see color changing like that with time. That tells you it's by mechanical pulping that it was produced because of the presence of lignin in it. So now let's look at the mechanical pulping process generally. It's a process by which fibers are produced through mechanical methods. Mechanical methods that we have here, one is the grinding stone ground wood, SGW, grinding stone ground wood method. In this case, you use logs of wood. It's very occasional that you use chips. With this method, you use logs of wood. Then the logs of wood are pressed into a turning stone, which helps to release the fiber. I will show you an example, a picture soon. Then you have the other one, refiner pulp. This one, you don't use logs of wood, you use chips. So, and the chips are fed in between two discs. One of the discs will be moving and one is fixed. Otherwise, the discs can be moving in different directions. Two discs can be moving in different directions. And then you feed in the chips and it will crush it. Or one disc is moving and one is fixed. Then in this case, often heat is used, you heat it and you pre-treat it with chemical. We'll see the chemical that is used as we go on. So mechanical pulping, therefore, is the method of converting logs or wood chips into paper pulp for the use in paper making, which is accomplished by mechanical grinding. Then, sorry. I think I am okay. So, general information about mechanical pulping. Look at the raw material quality. Pulps cannot be brightened very much. So the quality will not be that good because of the bleaching method that we use for mechanical pulping. So chips used should be less than 2 weeks old. These are the things you must consider when you're carrying out mechanical pulping. The chips that you use should be just less than 2 weeks old, not the wood that has been kept for so long. This is because of oxidation and biological decay, which can lead the chips to be dark, very dark, after you carry out the pulping. So after 2 weeks, the chips will not be that good. Oxidation and biological decay will take place. And so low back and dirt tolerance. Do not tolerate back, it will not tolerate low back and dirt tolerance. Color and machinery. So so this leads to color and machinery wear issues. So it should be low back, as you must have debark it well. If you don't debark it well, then of course that brown color will, from the bark will be introduced into it. And then also, it cannot tolerate dirt too much. Otherwise, if there's too much dirt, then it will wear off the machine that you're using. Then this method, mechanical pulping, is species dependent. Particular wood that you need to use should be the exact that should be used. So different wood species, they work better in different processes. So there's some certain species of wood that are useful, that are better for mechanical pulping. All this I'm going to show you as we go on. So I think I've already mentioned this. This is it's a repeated slide. It's a repeated slide. So for mechanical pulping methods, you have ground wood pulp, you have refiner mechanical pulps, you have semi-chemical pulps, you have chemomechanical pulps. All these are mechanical pulping methods, which we're going to see in the course of this lecture. Might not be today, but in the course of this course, we will see all those different types. The pulp and paper industry converts wood and converts wood or recycled fibers into pulp and primary form of paper. So you can use wood, you can use fiber, recycled fiber, even cotton clothes can be used to convert it to pulp and then to paper. So the purpose of pulping is to reduce wood or other fibrous material, raw material, into individual cellulose fibers. Remember, I've told you that wood is mainly cellulose and then the lignin that binds it and so on. So you will carry out pulping so as to reduce wood into individual cellulose fibers. So a non-fibrous constituent of wood, which is lignin, binds cellulose fibers together and is primarily responsible for reducing paper quality and its permanence. Permanence in a way that with time, the color is not permanent. With time, it keeps changing, like I explained to you before. And the lignin is where the chromophores are. So chromophores I mentioned are the color forming species in the wood. In the 18th century, in the 18th, there was a shift. So this is a little bit of history. Initially, at the beginning of pulping, it was cotton racks that were used for paper production, racks and all those cut from cotton clothes. Racks were used, converting them to pulp and then converting them to paper. So that's along the line, it's not just wood, it's not just cotton, it's not just racks that were used. It became important that wood is used. Wood became the most important source of fiber instead of using racks of cotton and so on. So first, Mechanical and then chemical method had been developed to produce pulp from wood. I'll go back to this. Initially, from the beginning of production of paper, it was cotton rags, clothes that were used. Produce pulp and the pulp used in producing paper. But along the line, wood directly itself became an important source of fiber. So, and initial pulping method was mechanical, and then along the line, the chemical method was developed also to produce wood, produce pulp from wood. Traditional mechanical pulping involves forcing logs against a revolving stone. Logs of wood, force them against revolving stone, and this helps to grind the logs into the pulp by the abrasive action. Then the stone is sprayed with water to remove the fibers from the stone and also to prevent the fibers from being damaged due to the friction during the process. And also, of course, you know, heat will be generated during the process. So water is poured in to remove the fibers from the stone and also to prevent the fiber from being damaged due to friction that is generating heat. And so production of mechanical pulp, which also is called groundwood pulp, it results in little removal of lignin content. And the consequence of this is producing paper that is not of high quality and not as compared to other pulping method, chemical pulping method. Because in chemical pulping method, almost all the lignin is removed. And so you have little or nothing that is remaining there to reform the chromophores. But in mechanical pulping, almost all the lignin is retained. And so the whole chromophores are still there. So now, this is a schematic representation of mechanical pulping method. So you see where you put in the log of wood, you put in here to debark it first. You carry the log of wood and you debark it. Then after debarking it, you move it to chipping. Like I mentioned, you can either use chips or you use logs, depending on what method you're using. If you're using groundwood pulping, of course, you can use log. If you're using refiner pulping, you have to use chips. So, and then you pass it for the grinding here. Then if it is for the groundwood pulping, you pass the logs here for grinding. And then when you have gotten your pulp ground, the fibers here, you move it to screening. That's where you have the sheaves that are removed, those ones that were not properly crushed. You screen them here, and the sheaves or the rejects is removed. Of course, the sheaves and rejects can be treated and put back to the process. So, and then whatever you can no longer treat and put back is finally rejected. So you have the final reject. And then passing on from the screening, of course, after the screening, you have the reject and you have the pulp itself that is active, that is going in. So, and then the pulp that goes in, you do some thickening process, which you will see later on. And then you move it from there to bleaching. Like I said, mechanical pulp bleaching is completely different from chemical pulp bleaching. So in the mechanical pulp bleaching, the lignin is still there. So then you move the bleached pulp to market pulp. There are those that want to just buy pulp and make paper, or you go move it to the paper making mill. So that is this. These are the steps in mechanical pulping. Now I was saying I will show you how you carry out ground wood pulping. Say you carry logs of wood, as you see, and so you pass it through rotating stone. As you can see here, you pass a log of wood through the rotating stone, which crushes it and brings out the cellulose, as you see here, brings it out for the pulping. That is the ground wood method. And then it's important also to see the stones or the grinder here that can be used. So the grinder that is used is cut into certain pattern, just like a stone is cut into certain pattern, so that it will give that abrasive property. So when the wood gets into it, it will break it and crush it and bring it out. So this is it, and you have different patterns of cutting the stone. See the different patterns here. So you can have the thread, the stretch, the diamond, the spiral. So the patterns are 1.6 millimeter deep on the surface of the stone. The deep pattern. And then another thing you must do is, over time, you'll be sharpening it. You're sharpening it every 50 to 150 hours as you use the stone. So you keep sharpening it. And then what does the sharpening help to do? The sharpening is fracturing the softer bond pores. So this causes one grain to be removed, uncovering new sharp abrasive grains of the stone. So why do you need the sharp abrasive grain of the stone? You need it to expose fresh abrasive grit, just like sharpening a knife where it was blunt before. You have sharpened, you have removed whatever is getting it blunt, and it gets sharper. You do that also to control the compression and decompression frequency on the wood fiber. You do that to control fiber length. You do that to clean stone pores, because you don't want if you don't keep sharpening it, the spores will be clogged and blocked, and it will be much more blunt, and it will not be useful. So you to carry water into the grinding zone and pulp out of the grinding zone. So you keep it sharpened and the pores open, so that water, of course, remember I say ground wood pulp, when you're grinding the log on the stone, you need to pour water so that it will release the fibers, the cellulose out. So if it is sharp, it will easily help you to remove the water and carry the water inside to remove what you need to remove and bring out the pulp. So that is it. And then the method of making ground wood pulp was invented in Germany in the 1840s. It was the first process in which wood was used as raw material for paper making. Remember I said initially cotton rags were used. Of course, in that one, you cannot use ground wood pulp. So, but when ground wood pulp was invented in Germany, 1840s. It was wood that was first used as raw material for the paper making. So in this process, the barked wood logs are pressed against a rotating cylinder of sandstone, like what I showed you before, that have different cutting patterns. So while spraying with water to cool and wash the grinding stone so that it will still remain good for subsequent grinding, keep on grinding and be washing it. Then after some time, you sharpen it again. Okay, so this causes bond ruptures in the fiber wall. That is when you are grinding the wood with the stone. It causes bond ruptures in the fiber walls, and the lignin between the fiber gets softened. So fibers and fiber bundles are pulled out of the wood and broken down even more than stone and the wood surface. So the fiber comes out. And then the figure I showed you before that you use wood logs is the magazine grinder, which is the commonest type of grinding machine. It features two opposing wood magazines, and the wood of the magazines is pressed against the stone by hydraulic pressure. The largest grinding stone may have a diameter of 1.8 meters, and the motor rating is more than 7 megawatts. So a 7 megawatt motor is a powerful electric motor, which is capable of reducing, is capable of driving industrial machines like mills, crushers, and pumps. So that is a type of machine that is used, a type of motor that is used to drive the pulping mill. So the output is about 120 tons of paper per grinder per day, 120 tons. So there's more recent development, other types of grinder, like pressure grinder, in which grinding is carried out under positive pressure and with steam. So I'm going to show you that method, but this particular one we're talking of is the ground wood pulping. So we'll see the refiner pulping method, which uses this pressure and then steam. Okay, so just this is how it looks like. The grains in the surface of the stone penetrate into the surface, which is heated by friction and exposed to the shearing force at the same time. So what I showed you, it has a more complicated design than that of ground wood. And then the one that I showed you, then that was the magazine. So that the wood here must be passed in against positive pressure. The steam formed by the grinding heat can be used elsewhere in the mill. So pressurized groundwood pulp is stronger than ordinary groundwood pulp. So we have the conventional normal groundwood pulp, which I showed you that is using the magazine grinder. And then we have the pressurized groundwood pulp, which is making use of pressure, and steam is formed, and it's also useful there, and it can be used in another part of the meal or something else. So Pressurized ground wood, which we're just introducing, is a method of mechanical pulping in which wood is ground against an abrasive rotating stone, just as the ground wood method, but in this case under high pressure, and the temperature exceeds that of 100 degrees centigrade. You're talking of pressurized ground wood method. So it generates a better quality of pulp than traditional ground wood. That's the difference. So now we have refiner pulping method. It's also a mechanical pulping method. So here we have the different pulping methods that we will see mentioned before. We have refiner pulp, a mechanical pulping method is called RMP. We have thermomechanical pulping, TMP. We have chemi-mechanical pulping, CMP. From that name, you can see that a little bit of chemical is added. Then we have chemi-thermomechanical pulping, CTMP, means you add a little bit of chemical and you also add heat. So the differences between these systems are discussed. I have the note section that you will see, but I will discuss them with you as we go on. So now we want to take the refiner mechanical pulping method. The refiner pulp itself is an umbrella name for pulps that are produced by grinding wood chips in a Dix refiner. I told you we have different methods. For the ground wood, is the stone that you have cut the surface into some patterns that you're grinding with. But in the refiner pulp, and then in that ground wood, you use logs of wood. But in refiner pulping, we have an umbrella name. We have different types of refiner pulping. So the refiner pulp is an umbrella name for pulps that are produced by grinding wood chips in a disc refiner. As you see here, you have the two discs here, and the chip is being fed in between the disc, as you see. Like I mentioned before, the two discs can be rotating, against each other, or one can be rotating while one stays, and then it grind your chips. The chips are crushed and the fibers separated as the chips are heated and abraded toward the periphery. That's periphery. So electric power of motor is converted into heat. The large amount of steam are developed from the moisture in the wood chips. And I mentioned that the steam generated can be passed into any other part of the mill for another use. So steam is used internally in the system to steam and preheat the wood, and then you can still divert it to another section in the mill for use. Surplus steam can be used elsewhere in the mill. That's what I just said. The commonest refiner pulps are thermomechanical pulp, TMP, and chemi-thermomechanical pulp that I mentioned before, TMP, TP. So in both cases, the chips are preheated with steam at 120 degrees centigrade. With chemi-thermomechanical pulps, the chips are impregnated with sodium sulfite. This is sulfite, sorry. So you soak it in sodium sulfite, and then it is softened a bit before you moved it into the refiner in between the chips. So you heat it, chemi-thermo. You soak it in that solvent, in sodium sulfide solution, and then you heat it and then move it to the refining section, crushing. So mechanical pulping, so thermomechanical pulping processes. So here the hot sulfite, which is a combination of sodium hydroxide, sodium sulfite, is added together and you get the hot sulfite. So this is what you use in soaking the wood. The sulfite prevents the wood from darkening upon treatment. You also do cold soda, that is directly you can soak it in sodium hydroxide, and it helps to swell the wood. And then some hemicelluloses and all resins are lost, some. Then hemicellulose is also part of the wood. Soft woods resist this treatment, so use only for hardwood. So this method is used only for hardwood. So if you're carrying out chemi-mechanical pulping or chemi-thermomechanical pulping, you have to use hardwood. Okay, so the process now, alkaline, we're still on the process. What you use again is alkaline peroxide, sodium hydroxide and sodium, and then hydrogen peroxide mixture. So the pulping and the bleaching together, difficult with soft wood. For this one, for this method, it's difficult also with soft wood. And then you're doing the pulping and you're doing the bleaching together, in this case, when you're using alkaline peroxide. So, and it needs to stabilize peroxide against thermal degradation and also against degradation by metals. You will see when we get to that particular process. So silicates are also used to stabilize the peroxide. So they can be deposited on the refining equipment for stabilizing the peroxide. I'm talking of the silicates. So you have, for the thermomechanical pulping, you have 2 to 5% of sodium sulfite that is used. The most common of the chemical processes is this, of using thermomechanical pulping. The lignin is sulfonated to only a very slight extent, sulfonated to a very slight extent, and then this softens the lignin, making the fiber easy to be removed. So these are the different methods. We have the refiner mechanical pulping, thermomechanical pulping, chemi-thermomechanical pulping, chemi-mechanical pulping. So you see the differences between them here. In the heating time, the temperature, the chemicals that are used in soaking them, and the pH at which they run, pretreatment time, how long do you pretreat it, do you soak it, and then pretreatment temperature. So all these are here for the different processes. So you determine, sorry, it's like because we started a bit late. So you have to determine the end point, that is of the pulping. Determine the end point of the pulping. I think I'm going to rush here. So, but for chemical pulping, the end point determination is different. But for mechanical pulping, the determination endpoint that we use is called freeness. So Canadian freeness standard is what is used to determine the endpoint. So this is the endpoint. You take the pulp, You put it in the equipment as seen here, and you let it flow. So the freeness is a measure of how easily the water leaves the fiber. The measure of how easily the water leaves the fiber. So high freeness is showing that the fiber has not been well, the pulp is not okay yet. So you have to put it back for pulping. So then low freeness, you have like 50 mils of 20 mils of water running out. It takes time for it to come out, and then just little water coming out. It's low freeness, and it shows that the pulping is properly done. So when it is not yet properly done, the freeness is much. 750 mils of water. It moves out very easily, but when you pour it in this equipment, it takes time and just only 20 mils of water. It shows it's already thick. It has already, everything is well blended. So that is the end point. When you measure this freeness and you see it's well blended, then you know your pulp is okay. You can pass it to the paper making section. But if it is free flowing, like we see, it means it's not well blended. You put it back and repeat the blending. And so until you have the Canadian standard freeness, which is within the specification that you should have, like 20 mils of water. So that is how you measure, determine this. So, and the change in pulp color, what is responsible? I've mentioned this before, that since wood contains significant amount of lignin, mechanical pulps from highly opaque paper with good printing properties. So you have this mechanical, I don't know why. Okay, the paper that is made from mechanical pulp, it will change color. To have good printing property, that the color will change because of the lignin that is there. The lignin is sensitive to light and turns brown when it's exposed to sunlight. So the light with the oxygen now forms back the chromophore. With time, we will see all that, how the chromophore forms back in the paper. So this is why the paper made from mechanical pulp easily changes color on exposure to light over a period of time, because of the presence of the chromophore in the lignin. In short, because of the lignin that is there, because it's not removed, and of course, chromophores are present in the lignin. And so with time, exposure to oxygen and exposure to light, the chromophore forms back and the color gets brown. So advantages of mechanical pulping are with a high yield, and I mentioned almost everything of the wood, and every part of the wood that we put, almost everything is useful. Gives you about 95% yield. The cost is low cost because it produces much. The paper produces, and the paper it produces has several desirable printing qualities. It's printable, it absorbs ink easily, it is bulky, and so those are the good properties. And then the disadvantages are that the low strength of the paper produced from there has low strength and easily tear. Low performance, not that good. And then the tendency of yellowing is there because of the presence of high lignin. And then the paper made with mechanical pulp also contains chips, like I mentioned to you before, incompletely ground fiber bundles. You see some little things like that in the paper. You see it and you know that it's from mechanical pulp. So mechanical pulps are primarily used for newsprint. I think you can understand now why I say that it is not strong. Newsprint, as well as papers used in telephone directories, catalogs, magazine, paper towels, tissue papers, all those ones are from mechanical pulping method, so they're not strong. So that's the end of the lecture today. I don't know if you have a question for me. I will stop sharing. Do you have any question for me?
Yes, ma'am. I think we would like to go through the class again so that we can reflect
I'm
on.
not hearing you well.
I think we might have to go over the class again for me and see where we are lacking at. Maybe try out some questions in the next class.
Well, yeah, I don't know if I might, if I am sure I get you well. This lecture is already on YouTube. So immediately after this, I'm going to give you the link to this lecture so you can go over it over and over as many times as you want. I don't know if that answers your question.
Yes, it does. Then I think
Okay.
after we go over each thing, we might have one or two questions we want to throw out there.
Okay. So, but at the end of all the lectures, I think I will also give you time for us to have a discussion on all the lectures that I give you before your exam. So that will also help. So I will send to you the recordings, or in short, I will send to you the link so you can go back to the lecture